We want to start to look at how we can classify some functions now. And what we've got is, what we want to do is call some functions either odd or even. Now, the advantages of being able to distinguish that is that when we look at odd or even functions, we start to get some symmetry with our graphs. Now, if we know that we've got some symmetry, it makes them easier to draw up. And also, it tells us more about the features of the graph. Now, if it's an even function, it's going to have line symmetry about the y-axis. Remember what we've got to delve back to your year 7 days. That line symmetry basically is a mirror image in a line. So we've got our y-axis and the mirror image on either side of the line. So it'll be the same on the right hand side as it would on the left hand side. They'll match up. Now this is a graph of either a function of x squared, and you can see x squared has that symmetry. Now, how do we prove this without drawing it up? Well, it's a simple test to do. What we want to do is take our function of x and minus x, and if we get exactly the same as the function of x, then it would be an even function. So what do we mean there? Well, we know the function of x is x squared. If we put the function of minus x in, we get minus x and square it, which is minus x times minus x, so the negative will go, and we'll get x squared. Now notice that that's the function of x. So it gets back, no matter whether it's positive or negative, we get the same, basically we're saying we're getting the same y value. So where it's 1, we get positive 1. Negative 1 gives us a y value in positive 1. Negative 2 gives us positive 4. 2 gives us 4. So we start to see that no matter whether we put a negative value in or a positive value in, we get the same y value. That will give us an even function. So, but that's how we prove it overall. You can't just start subbing numbers in and go, oh yeah, it works. To prove something, we need to prove it for all values, which means we need to use algebraic symbols. Now, the other one we want to start to look at is when we have an odd function. Now, an odd function has point symmetry. So what does point symmetry mean? Point symmetry means that it will rotate around an x-axis. The origin, and be exactly the same. So if we can rotate it 180 degrees and have exactly the same function, then we will then it will be odd. So basically, you can take your computer screen here, turn it upside down, and see the same function. Then see the same graph. It's an odd function. And a couple of things. That will only happen if it's rotating around the origin. So our odd functions have to go through the origin each time. So if it doesn't go through the origin, then it won't be an odd function because you won't be able to rotate it and see exactly the same in exactly the same position. Now, how do we prove it? Well, this time, if we put our minus x value in, the function minus x, it will give us the function of x, but with a negative out the front. So we see x cubed here. We put in negative x, and so we substitute it in for the x there. So negative x all cubed would give us a minus x cubed, because x times x to the power of 3 is x cubed, and the negative times the negative times the negative still gives us a negative. So, but that was the function of x. If function of x is x cubed, so the function, we have the function there with a negative out the front, which means it is an odd function. And what does it mean really? Well, basically we get to 8, but if we put minus 2 in, we get the minus 8. So we get the same actual values, but when we put a negative value in, we get the negative of that value. So we can see 1, 1, 1, minus 1, minus 1. So we get the same values, but they're in the opposite quadrants. They're going to be cubed. So that's what an odd function does for us. Now, if we know something's an odd function, it makes it easy to draw because we know in symmetry there, it will be the same as we go down there. So that's where it starts to help us. It'll also help us when we're doing some integral calculus. So we use these ideas, starts to make our problems easier if we realize whether they're an odd or an even function. Now, so you're probably thinking, well, what if they're not odd or even functions? What if it's something else? What if it's not around the axis or around the origin? And that's okay. We just class them as neither odd nor even. So if it's odd or even functions, then that's good. If they're not, which probably the majority aren't odd or even functions, then that doesn't help us. But we look for advantages and use this where we can. So are these ones odd or even? Well, this one, yes, it would be. It's an even function because you can see that line symmetry, even though it's not going through the origin, but it's got a symmetry on the either side of the axis. This one is not an odd function because we can't rotate it around and get exactly the same. If we rotate that, it would come down here and be looking like that, basically. So it's neither. So this one, even function. You can see that nice symmetry. This one is an odd function. Okay, you see it. If we rotate it 180 degrees, you get exactly the same. This function, again, would be odd, because again, if you rotate it 180 degrees, you're seeing exactly the same. So we'd give it, it'd be an odd function. Even though this one's a parabola, it's neither, because it doesn't have symmetry around that y-axis. It's got an axis of symmetry, but it's not around the y-axis. The even function has to be symmetry around the axis, y-axis. So you're proving now using negative x. So see if it's an odd function or even function. We sub it in. Sub in minus x. So we get minus x all squared minus 2, which gives it back to the x squared minus 2, which is what we started with. So it's an even function because the function of minus x is equal to the function of x. So all the x values, no matter where we put them positive or negative, will give us the same y values. Function of x is equal to x cubed minus 3x. So we put the minus x in. And we do a little bit of manipulation. This gives us minus x cubed plus 3x. But if we factorize the negative out, it becomes x cubed minus 3x, which is back to what we started with. So it's going to be written as minus of the function of x, which makes it an odd function, and that's okay. This time, x cubed plus 1. So we substitute x cubed minus x in there. We get minus x all cubed plus 1, which gives us minus x cubed plus 1, which we can't manipulate to get it back to the function of x. So it's neither. So it won't be an odd function or an even function. This time v is equal to 8x x power of 8, 3x power of 4 minus 2x squared, which we sub it in, and we get back to the same function. So we do our multiplications, clean it all up, we get back to what we started with, which is an even function there. So we can see how we start to manipulate these ones. Put minus x in for 4x minus x cubed. Again, manipulate it. When we get it out there and factorize that negative out, we get back to our function, which makes it an odd function. And x to the power of 4 plus x squared minus x, sub it in, and we get x to the power of 4 plus x squared back to what we started with. It's an even function. So what you're probably looking at here as well, and hopefully I'm starting to make connections, is that even functions need those even powers in there, and odd functions need those odd powers in there. It doesn't guarantee them to be odd functions or even functions, because you could have x to the power of 4x squared plus something else and it might not be an even function. And same thing with the odd functions. But you need them to have odd powers to be an odd function. You need them to be even powers to have an even function. Doesn't guarantee it, but you're going to have to see that. So hopefully you're making that connection. I'm sure you were.